So here's what you posted on there,
You know,
McKenna.
I don't do all these right now, but I'm just getting all the ones that ain't done now.
And so if we look at this problem right here, this is from the section on sampling distributions. It says we've got a population, and our population. Yeah, is there a question?
Can you hear me? Sorry.
Yes.
Okay, I got my sticker worked in. Thank you.
Okay, super. So we'll just have you, if you're not speaking, we'll just have you mute. Let's see. I think
Is
I
it
can
on
mute.
mute?
I got it right there. I can mute you guys. You guys can unmute.
Oh. Yeah, that's what these are.
Yeah, we should all be on mute now. But you should still be hearing me. Okay, so the idea is we've got this population, and the population are these three. The numbers of people in households are 1, 3, 8. That's our population. And we're going to take samples of size 2 from these, all the samples we can of size 2 with replacement. Okay, so I could have a 1, and then I could get another 1. I could get a 1 and a 3, a 1 and an 8. Okay, and then I can keep going, 3 and then a 1, and then a 3 and a 3, and then a 3 and an 8. 8 and a 1, an 8 and a 3, and an 8 and an 8. So those are the 9 possible samples of size 2. And what I'm interested in is this, the proportion of even numbers. Okay, so the only even number is 8. So if I write down the proportions in my first example, in the 1, 1 example, I have 0 out of 2. So that's 0. That's 0.0, right? 1, and in my second example, the 1, 3 example, there are again 0 out of 2. Now here I have a proportion of 0.5. Here is a proportion of even numbers 0, 0, 0.5, 0.5, 0.5, and then 1. Okay. So that is did I all right, so okay, so we're working on this one real quick. So and I see another one we'll look at here in a second. So construct a probability distribution table that describes the sampling distribution of the proportion of even numbers. So now if I take that data and put it in a table, I list the possibilities. I either have 0, 0.5, or 1, and 0. Sorry, not 0. The probability or let's see, what do I want to do? Construct a probability distribution. So this is P of X. So for zeros, I get that 4 out of 9 times. For 0.5s, I get that 4 out of 9 times. And 1, I get that 1 out of 9 times. Okay. So that is the probability distribution table that describes the sampling distribution of the proportion of even numbers when samples of size 2 are randomly selected. Now, does the mean of the sample proportions equal the proportion of even numbers in the population? So, the mean of the sample proportions. So I want to calculate the mean of this right here. The mean of this, the mean of all of the samples. So in other words, I could find the mean there, or find the mean of the probability distribution. Either way, but let's do it this way. Let's find the mean of these numbers. Okay, so just the average of those numbers. So I add them all up and I get a 0 plus a 0 plus a 0.5 plus a 0 plus a 0 plus a 0.5 plus 1. Okay, so I get 3 and then there are 9 of them. Boom. And so that the average, the mean of the proportions is 0.33 or 1/3. I mean, that keeps going. 1/3. All right. Does the mean of the sample proportions, so the mean of all of these sample proportions, equal the proportion of even numbers in the population? Well, look at your population. The proportion of even numbers is 1/3. And so look, they do equal. Okay. Do the sample proportions target? And the answer is yes. Does this, because that's the same. Does the sample proportion make a good estimator of the population proportion? Yes. So the answer to both of those questions are yes. All right. So there's that particular question. I forget who asked that. I think it was McKenna. Does that make sense, McKenna? Or what would you like to ask further on that? And again, this is be a good chance to, if your mic's working, probably easiest to. Okay, yes, I got you. I see your response there. Okay, moving on. So I see another one here. So we're recording this, so if anybody wants to revisit it, they can. So here's the next one we're looking at. And I just, while I'm setting this up, I want to remind you, keep track of those deadlines, right? We've got lots of things going on right now. You got to keep up, right? So make sure you're keeping up and understand that there are lots of online tutors available to help you. I've posted links in the at the front on the homepage of Canvas for you to access those. So I would check those out and I would visit those tutors often. All right, let's see. 3 random, no wait, this is the same one. What is that all about? Copy and paste the same thing. Let's try that again. All right, so here's another question. When 2 births are randomly selected, the sample space, boy, 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 girl, girl, boy, and girl, girl. Those are the things that can happen when you have 2 births. Assume that those 4 outcomes are equally likely. Construct a table that describes the sampling distribution of the sample proportion of girls from 2 births. Right? So the sample proportion of girls. So remember, our situations are boy, boy, that's 0 girls. Boy, girl, that's 1 girl. Girl, boy, that's 2 girls. And girl, girl, that's 2 girls. That's 1 boy. So we're either going to get 0, 1, or 2 girls. So this is going to look a lot like what we just did, right? The proportion of 0 is 1/4. The proportion of 2 girl of a single girl is 2/4. And the proportion of 2 girls is 1/4. Okay. And so there's the table that describes the sampling distribution of the sample proportion of girls. Okay. And then we're doing the same thing. Does the mean, so these are, let's see, let me squeeze these in here. So the mean there, or the proportion is 0/0, so that's 0. 1/2, so that's 0.5. 1/2, that's 0.5, and 1. So now they say find the average of these things. So I add those up, I get a 2/4. So the mean of those is 2/4 or 0.5. Okay, does the mean of the sample proportions, that's what we just found, equal the proportion of girls in two births? The mean of the sample, does it equal the proportion of girls in two births? Well, what do you think? What's the proportion of girls in two births? Sorry, let me get this fixed real quick. I'm getting trouble here. Sorry, give me 1 second. It's not working for me. I have to reset it. Hold on 1 second, everybody. All right. Okay, I think we got it now. So our population is either boys or girls. So, okay, so we calculated, let me go back. We calculated the mean of the sample proportion. That was right there. That was just the mean of these numbers. And then the proportion of girls in two births. When we talk about this, the population is either boys or girls. Okay. And so the proportion of girls in those two is 1 out of 2, or 1/2, or 0.5. So look, those two are equal. That's what we were asked. Is that equal to that? And the answer is yes. And because they're equal, then we then that suggests that we're working with an unbiased example, right? So the answer to that last question, um, does the result suggest that a sample proportion is an unbiased estimator? And the answer is yes. Okay. So the trick is remembering that in two births, we either get boys or girls. So that's the population. All right. So there's another example. That's the same kind of deal. All right. So this is section 6.3 homework. Just so you know, right? Today you should be looking at 8.2 or 8.3, right? So you've got to, right? I know that things are kind of crazy. I'm just want to get you encouraged to move forward now, because you'll have lots of things happening. Anyway, what other questions? Do you have other questions? You guys still hear me out there? Yeah, so is there anything else I can help you with? I've thrown up, while you're thinking of questions, um, I've thrown up lots of videos covering these sections, and of course you can watch the 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 videos in my stat lab. So make sure you're keeping track of those as a way to learn the material. Yeah, so what question do you have, Talisha? If you want to hit your mic and tell me, that would be cool.
Hear me?
Yeah.
Okay. Uh, there's no question that I have. I was just saying yes, I could hear you.
Oh, okay, okay, okay. So everybody's on track and doing okay. I mean, just there's lots of work to do. I'm looking ahead, right? Today being the third, no, today being the first. I get to the right. Yeah, so being the third, we've got 6-3 due, and then a quiz is due also on the third, and then on the 8th, we've got 4 different things due. On the 15th, a couple things. Um, be aware there's some chapter 6 stuff that's coming up. I've given you more time on the test, so be careful. It's overlapping some chapters 7 and 8 stuff. So just pay attention to those deadlines, but I give you more time on the tests generally. Yeah. Okay. And also, right, everything is done by like the 21st or 22nd. Okay, so we can't go past that date because that's when these things are due, or that's when final grades are due. So, you know, you're having some time on these things, but it will start to cram together here. We will have maybe a chapter 9 test because we're done with chapter 8. So at the end of next week, we'll throw up a chapter 9 test and then a couple quizzes and things like that. So right now we've got, I mean, if you look right now, you've got a chapter 6 test on my stat lab ready to roll. Yeah, so the 6 test is there, the 7 and 8 test is there, and then the 9 test will be there. And then we'll think about the final a little later. So 3 tests left, and then the final. Yeah, lots of work. Lots of work. All right, guys, if you don't have any other questions, then I'll send you on your way and we'll get this I'll get this posted for you to see if you want. Otherwise, we'll see you next week.